Hi everyone, welcome back to my video again. This is System Thinking in Engineering Mechanics. So today we will talk about the basic concept of three-dimensional vectors. Don't forget that we have the step of additioning of the several vectors, and in three-dimensionals as well. We will go to all of these steps of the two dimensionals, but we add more in terms of the first step, the component. We add more in terms of x, y, and right now there are the c's. And step 2 as well, so we will have to combine the c components, and then after that, for the last step, we should find the magnitude and the angle of the resultant vector. In terms of the three-dimensional vectors, all of these examples come from the Hibbeler's textbooks. So, according to my experience, they have about three systems that the question will give you in terms of the three-dimensionals. The first one, I will call this is the triangles systems. It means that the question gives you three angles between the force and the axis, just like F2 here. And you can also get the second one that I call the two angles systems. In these systems, you will get only two angles. One angle is between F and the plane. Another one is between F and any exit. And the last one is the position systems. In this system, they didn't give you any angles, but they give you the start and the end position. And also you can see that some term of angles can be given you in terms of the triangles like this, as the same as the two-dimensional vector. Let's start with the first one, the triangles systems. And because of all of these triangles from F2 here was set between F and the coordinate vector or coordinate axis already. So you can use the concept of cosine to find out the vector of this one. We can write down that vector F equal to the magnitude of F cos theta in terms of I plus magnitude of F cos beta in terms of J, and then magnitude of F cos gamma in terms of K. And don't forget that theta should be the angle that F acting on the x-axis. Beta should be the angle that F acting on the y-axis, and so on the gamma should be F and the C axis. So for F2 here, we can write down that it is 400 newtons, the magnitude of F, and then this is the angle between F and x-axis. So it is cos 120 I plus 400, and right now we have 45 cos 45 J, and then 400 cos 60, because this is the angle that F acting on the C axis. After that, you can do your calculation to find out all of these numbers. And this is the first system, triangle system. Let's go to the next one. This is what we call two angles systems. So it means that they give you only two, and you can see that this 45 is the angles between F2 and plane XY. So to be clear, let's try this. If you have the box like this, and if I draw the line here to here like this, so if I cut this box diagonals, I can get the half of box like this, which should have the half of box like this, which should have the vectors on this plane on the yellow area here like this. So if you look in this size by using the engineering drawings and anything, you can see this plane as two-dimensional like this. So let I say this is A, B, C, D, and E. I will give the point to all of these names, and this is A, B, C, D, E, F. So this two-dimensional plane will be A, C, E, and F. So according to the questions here, they give you 45 degrees here. So it means that you can find out the components between AF as F2 sine 45, and then AC F2 cos 45, which is this one F2 sine 45, and then this one F2 cos 45. And you can see that this term F2 sine 45 is already in the C axis. So it is the component of F2 in C axis already. But for this term is not on any axis yet. So we have to look at them again on this plane. So if I look down on this plane again, I will have the rectangular A, B, C and H which have this vector f2 cos 45. So I can find out, and the question gives us 30 degrees here. So we can find out this one as this term sine 30 and f2 cos 45 cos 30. So this one AH is along the y-axis, and for this one is along on the x-axis. Finally, we can write down the force 2 in terms of vector as f2 cos 45 cos 30 I plus f2 cos 45 sine 30 j, and then plus f2 sine 45 k. Please don't forget to check that there is cos and sine of 45 and then cos and sine of 30, which is another angle that was given. So again, of two angle systems, I have some steps that you can use it. If you already clearly understand all of these steps. So let's start with the closest angles of force or of any vector that you want to find out the component. So from here 45 is closer angles in this system. So let's do on the 45. You should get f2 cos 45 here, and then f2 sine 45 here. And this one you check, this one is on plane xy, it's not in any axis yet, but this one is on the z axis. So this one is finished. So after that we use another angles. On the green one, put all of them here, and then it is cos 30, and the purple ones here, put the term on xy plane and then sine 30. So you check it again. This one is on the y-axis and this one is already on the x-axis, and that is. So we can write down that vector f2 is f2 cos 45 cos 30 I plus f2 cos 45 sine 30 j, and then f2 sine 45k. Let's go to the last system here. Is the third one, positions vectors. They have a lot of steps in this type of vector, but it's very easily to understand. So we have to find out the step like this. So I will write it from the backward. F in terms of vector will be equal to the size of F and then the unit vector along that line. To find out the unit vectors along that line, you should find out the vector R, and then you put the magnitude of the vector R to divide it. So you should have the size of vector R and then the vector R. Let's see FB for the examples. Vector R of FB start from A to B. We can use as the position. So R from A to B is the position of B minus A, which is the B here is T along the X and then Y of 2 meters and then 0 of the C exit, minus with 0 here and 0 in terms of Y axis and then 6. So you should get RAB, the vector RAB as 3 2 minus 6, or we can write down it as 3i plus 2j minus 6k. Another step that I always use is I will start from here, the starting point, and then I will go along to find out the point B. So I go this way. It is minus 6k along the C exit, and then go this way as T in terms of the X axis, and then this one minus 2j. After that, guys, I think there's some mistake before the here, so I will write it back again. If you use B minus A, it should be the point B is 3 minus 2 and 0, and I forget to put the minus sign in here, minus 0 0 and 6. The magnitude of this vector can be found out in these equations. Square root of each term square. So the result of this is 7 or square root 49, and then the unit vector of this unit vectors are AB, or you can write down it as unit vector AB is 3 over 7i minus 2 over 7j minus 6 over 7k. And the last step, you put the magnitude of f here, you can find out the vector f will be equal to 840 multiplied with all of this. So you can cut this out, and this is 120. So the final result is 360 I minus 240 J and minus 720 K. And that's it for this video. Thank you for watching. See you next video.